bird doesn't get electrocuted when perched on a power line for several reasons. Firstly, power lines are typically insulated with rubber or plastic materials. This insulation prevents the transmission of electrical current at the outside surface of the line, creating a barrier between the bird and the energized conductor. Secondly, birds have dry feet, which do not conduct electricity well. When a bird lands on a power line, its feet only make contact with the insulating material, preventing any significant current flow through its body. Thirdly, birds usually perch on both wires simultaneously, 1 foot on each. This creates a balanced electrical circuit, with the current flowing through the bird's feet and back out through the other foot to the other wire. Since the bird's body is not completing a path to the ground, it does not experience any electrical shock. Fourthly, power lines typically operate at high voltages, in the thousands of volts range, but at relatively low currents, typically less than 1 amp. While high voltage can be dangerous, it is the current that flows through the body that causes harm. The low current in power lines is not typically sufficient to cause significant harm to a bird. Fifthly, birds typically only perch on power lines for brief periods. During this time, the amount of electricity that passes through their bodies, if any, is minimal, further reducing the risk of electrocution. It's important to note that it's not always safe for birds to perch on power lines. If the insulation is damaged or the bird makes contact with a live conductor, it can be electrocuted. Additionally, certain bird species that have wet feathers or larger bodies may be more susceptible to electrocution. The reason why the insulation is effective is that it provides a high resistance path, significantly limiting the flow of current. Electrical current seeks the path of least resistance to return to the source. When a bird is perched on a single wire, its body essentially becomes a parallel path to the wire itself. However, because the bird's body, especially with dry feet and feathers, offers significantly higher resistance than the power line conductor, very little current will choose to flow through the bird. The amount of current that would flow through the bird, calculated using Ohm's law, would be far too low to cause electrocution. For a bird to be electrocuted, there needs to be a significant potential difference, a voltage difference across 2 points on its body and a relatively low resistance path between those points, enabling a substantial current flow. This is typically not the case when a bird is perched on a single, insulated power line. The principle of balanced perching relies on the idea that the bird is at the same potential as the wire it is standing on. Electrical potential is the amount of electrical potential energy at a point in an electric field. Since both feet are on the same wire, there is no potential difference between them. Without a potential difference, there is no driving force for current to flow through the bird's body. This is analogous to a person standing on a single step of a ladder. There is no height difference, and thus no potential energy to be converted into kinetic energy. Power lines are designed to carry large amounts of power efficiently. High voltage is used to reduce current for a given amount of power, which in turn reduces losses due to resistance in the wires. The power loss in a conductor is proportional to the square of the current according to Joule's law. Therefore, by increasing the voltage and decreasing the current, the power loss is minimized. The low current, even at high voltage, is a factor in why birds are generally safe on power lines. The current needed to cause significant harm depends on several factors, including the duration of the shock, the path of the current through the body, and the individual's physical condition. However, generally currents of only a few milliamps can be felt, and currents of 10 milliamps or more can cause muscle contractions. Currents of 100 milliamps or more can be fatal. The current that might flow through a bird perched on a power line is typically far below these levels, especially if the bird is only in contact with a single wire and its feathers and feet are dry. The duration that a bird is perched on a power line also plays a role. The longer the duration, the greater the chance that something could go wrong, such as the bird touching another wire or a grounded object, or a change in the condition of the wire or the bird itself. However, since birds typically perch for only brief periods, the risk is reduced. In addition to the factors already mentioned, the design and maintenance of power lines also contribute to bird safety. Power companies take measures to minimize the risk of electrocution to birds, such as using insulated wires, increasing the spacing between wires, and installing perch guards to prevent birds from landing on hazardous locations. These measures are particularly important in areas where there are large populations of birds or where there are known risks of bird electrocution. Certain conditions can increase the risk of electrocution to birds on power lines. One such condition is wet feathers. Water is a good conductor of electricity, so wet feathers can significantly reduce the resistance of a bird's body, making it more susceptible to electric shock. Another condition is contact with multiple wires or with a grounded object. If a bird touches two wires at different potentials, or if it touches a wire and a grounded object, it can create a low resistance path for current to flow through its body, resulting in electrocution. The size of the bird also plays a role. Larger birds have a greater wingspan, which increases the chance that they will come into contact with multiple wires or grounded objects. In addition, larger birds may have a lower resistance than smaller birds, making them more susceptible to electric shock. The presence of damaged insulation can also increase the risk of electrocution. If the insulation on a power line is damaged, it can expose the live conductor, creating a potential hazard for birds that land on the line. Regular inspections and maintenance of power lines are therefore important to ensure that the insulation is in good condition and that there are no other hazards that could pose a risk to birds. The types of power lines themselves can also influence the risk. Distribution lines, which carry power from substations to homes and businesses, typically have lower voltages than transmission lines, which carry power over long distances. Lower voltage lines are generally less dangerous to birds because the potential difference is lower, and therefore the current flow is less likely to be lethal. However, distribution lines are often more closely spaced than transmission lines, which can increase the risk of a bird coming into contact with multiple wires. Bird electrocution is a complex issue with a variety of contributing factors. While birds are generally safe when perched on power lines due to insulation, dry feet, balance perching, high voltage, low current, and short duration, certain conditions can increase the risk of electrocution. Power companies take measures to minimize these risks, but it is important to be aware of the potential hazards and to take precautions to protect birds from electrocution. The study of bird electrocution and its prevention is an ongoing field of research. Scientists and engineers are constantly working to develop new technologies and strategies to reduce the risk of electrocution to birds on power lines. These efforts include developing new types of insulation, improving the design of power line structures, and implementing bird deterrent measures. The ultimate goal is to create power lines that are safe for both humans and wildlife. One important area of research is the development of bird-friendly power line designs. These designs aim to minimize the risk of electrocution by increasing the spacing between wires, using insulated wires, and providing perches that are safe for birds. Some designs also incorporate features that deter birds from landing on hazardous locations, such as spikes or wires. Another area of research is the use of bird deterrents. These devices are designed to discourage birds from landing on power lines. Some deterrents use visual cues, such as brightly colored streamers or flags. Others use auditory cues, such as recorded bird distress calls. Still others use physical barriers, such as nets or screens. The effectiveness of bird deterrents varies depending on the species of bird and the specific situation. It is therefore important to carefully select and implement deterrents to ensure that they are effective and do not cause harm to birds. The prevention of bird electrocution is a shared responsibility. Power companies, government agencies, conservation organizations, and individuals all have a role to play in protecting birds from this hazard. By working together, we can create a safer environment for birds and ensure that power lines are compatible with wildlife. Education is also an important component of bird electrocution prevention. By educating the public about the risks of bird electrocution and the measures that can be taken to prevent it, we can raise awareness and encourage responsible behavior. This includes avoiding activities that could damage power lines, such as flying kites or shooting at insulators, and reporting any damaged power lines to the power company. In addition to the direct effects of electrocution, power lines can also have other indirect effects on birds. Power lines can create a barrier to bird migration, forcing birds to fly around them, which can expend energy and increase the risk of collision with other objects. Power lines can also provide perches for predators, which can increase the risk of predation for birds. The cumulative effects of these direct and indirect impacts can have significant consequences for bird populations. For this reason, it is important to consider the potential impacts of power lines on birds when planning and constructing new power lines. This includes conducting environmental impact assessments to identify potential risks and implementing mitigation measures to minimize these risks. The location of power lines is also an important consideration. Power lines should be located away from important bird habitats such as nesting sites, feeding areas, and migratory routes. When this is not possible, mitigation measures should be implemented to minimize the impacts on birds. These measures can include using bird-friendly power line designs, installing bird deterrents, and providing alternative perches for birds. The ongoing efforts to prevent bird electrocution demonstrate a commitment to protecting wildlife and ensuring that power lines are compatible with the environment. By continuing to research and develop new technologies and strategies, and by working together to implement these measures, we can create a safer future for birds and other wildlife. The principles of electrical safety that protect birds on power lines also apply to human safety. Understanding the concepts of voltage, current, resistance, and insulation is essential for working safely with electricity. Never touch a live wire or any electrical equipment that is not properly insulated. Always use appropriate safety gear, such as gloves and eye protection. And if you are unsure about how to perform a task safely, consult a qualified electrician. Electrical safety is not just about protecting yourself from electrocution. It is also about protecting others. By following safe practices, you can prevent electrical accidents and ensure that everyone stays safe. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. If you have any questions about electrical safety, consult a qualified electrician or other expert. Staying informed and taking precautions can make a significant difference in preventing electrical accidents and protecting both humans and wildlife.